So today we are going to be talking about large language models and predictive models and sort of trying to understand how to think about and what sort of some of the possible ways are to think about aligning predictive models like potentially large language models. So I've sort of alluded to this topic a bunch of times previously, said that I would eventually try to cover it, and today we're going to try to do it justice. So yeah, so I'm going to start with a bit of a preliminary. So this is a bit of an aside, but we'll see later why this is an important thing to sort of cover in this context. So I want to introduce you to the eliciting latent knowledge problem. So what is the eliciting latent knowledge problem? So let us suppose that we have a vault, and inside of that vault there is a camera that's sort of keeping tabs on the vault, trying to understand, give us information about what is in the vault. And we've got a diamond in that vault that we want to protect. We want to make sure that the diamond in fact stays in the vault. One problem that you might have in this setup, if you were just sort of trying to watch that camera and understand whether the diamond in fact stays in the vault, is that somebody could spoof the camera. So there could be a situation where maybe you hold up a little sign in front of the camera that looks like a diamond, and then you actually take the real diamond and you steal it. So this is an example from ARC, the Alignment Research Center, where they're sort of trying to showcase a situation where sometimes if I had there's sort of knowledge about the world that we care about that may not be represented in the particular observations about the world that we get to see. So in this case, we can imagine sort of training a model to predict what our camera would show in this vault. And in the situation where a screen is put up in front of the camera, the prediction of that model would continue to be, it looks like there's a diamond in the vault for all of the observations that we checked. But in fact, there might not be. It might, in this situation where there's a screen in front, the diamond might actually be gone. And it may be the case that our model knows in some sense that the diamond is not there. But even if it in some sense knows that the diamond is not there, it's just trying to predict what the camera would show, and the camera still shows a diamond, so it's still going to predict a diamond. And so we sort of have this potential problem where sometimes when we ask our models to do things that are predicting observations about the world, there may be information that those models have access to that we can't directly get at via those observations. OK, we'll see why this ends up being relevant later, but I just want to make sure people understand this basic setup. OK, so we're going to go into this a little bit more. So here's how I want to sort of focus in on this predictor in the ELK case, right? In the ELK, it stands for eliciting latent knowledge. We have this predictor, right? It's predicting these cameras. We have these camera observations, and it's trying to understand, and predict each new frame. What is this camera going to show in this vault? And so we can try to understand what a model like that might be doing. How might it be structured? And so, in some sense, well, there's some model of the world that it's keeping track of. It has to model the world in some sense and try to understand how the world operates, and has to model the world over time and how it changes. And then it has sort of particular aspects of the world, parts of the world that are dependent on that world state. And then some of those aspects of the world get observed and end up in the camera. And so it predicts what the camera will show at various different points in time. And for example, there are some parts of the world, like the wall that the camera is mounted on, that it might sort of understand how those flow from its model of the world, but don't show up in the observations because they're not something the camera is looking at. Yeah, question.
So if it already has a model of the world, why can't we just get it to tell us what it predicts will happen in the world directly?
So why can't we just get it to predict what happens in the world? Well, the problem is, what does that mean, right? Like, what are you predicting, right? If you're not predicting some concrete process that can observe the world via some mechanism, then what is it that you're actually asking for, right? If there's no camera that would show you, the thing that you want, or you don't know how to find a camera or get a camera that would show the thing that you want, then what are you even predicting, right? Like, what is the fundamental thing you're asking for? Like, in some sense, what we really want is it's like, well, there is some knowledge of the world, but that knowledge of the world is not necessarily accessible via any observation that we might know how to ask for, right? And so you can't just sort of, to the extent that one can sort of train a model to just do a prediction task, you're sort of very limited to predicting things that one could observe in the world, right, via some mechanism of observation. And there may be things about the world that one can't observe via any observation, right? There's no camera that you could set up that would maybe show you something, or we don't know how to set up camera, or there isn't a camera that shows you some particular observation, despite the fact that there is something about the world that is like in fact true or false.
But is that like a limitation of what we can get out of the observations, or a limitation of what the model can get out of the observations? Like, are we assuming the model knows the diamond is gone?
We're assuming that the model could know. That the point is that the model might know, the model might not know, but in either situation, we would not be able to extract that from the observations. We're mostly going to be sort of imagining that the model does know, that it's sort of, in this sort of situation, the model might know that there's that whether the diamond is actually there, but we can't extract that via the observations because the camera won't show the, whether what is actually happening with the diamond. It'll only show what an actual camera would show because that's what the model's doing. It's just predicting the next frame of that camera. Yeah, question.
So, I mean, I guess you say camera, but like it could be many things. I mean, could it be like a whole network of satellites that are orbiting the Earth and like every surveillance camera ever? So, I mean, how would this affect the scenario? If you have multiple cameras, then...
Yeah, so absolutely. Your camera could be a lot of different things. And later, we'll see a particular sort of notion and instantiation of a camera that I think is particularly relevant. But absolutely, yes. There's a lot of various different things that could occupy the spot of camera here. And if your cameras are very expansive, they have the ability to really get lots of information through your observations, then you get access to more. But there's still a fundamental limit to how much you can get access to and what your thing is actually doing, right? In this situation, regardless of what your camera is, it's not telling you true information. It's telling you what it predicts that particular observational instrument would show, right? And that's different. And so that's sort of the important point that we sort of want to understand with like what this sort of predictor model might be doing. Yeah. Question.
So when we are saying observation, what is the relevant difference? Like in human language, it seems the same to describe please predict what the camera will show and please predict what will be on the table. And we want to actually predict that the diamond is on the table. Is the relevant difference that the camera's observation is more of actual digital code and we can more easily encode that this is the thing, while thing on the table is harder to translate to its
No, even in that case, in some sense, the point is that it's a little bit hard to understand, what exactly is a human doing when they say, the thing is on the table. I think that you could imagine that what the human is doing when they say that thing is on the table is they're just saying, well, I think I'm going to continue to observe it on the table. In fact, oftentimes we mean something different. We mean like, no, really, in base reality, there is in fact a thing on the table or whatever. I think the thing I'm sort of pointing at the very least is that we don't know how to train a model, certainly, to say that second thing. It's a little bit unclear whether we even know how to train a model to do the first thing, but we might at least know how to train a model to do the first thing, where you can give it a concrete observational procedure and in fact get observations that were produced from that procedure and then train a model to continue that sequence. If you just sort of are doing naive sequence continuation on a bunch of observations, you're going to expect it to do something like continue those observations. What are additional observations that you would expect from that process? You wouldn't generally, being able to in fact get it to give us, some sort of true representation of its beliefs about base reality, whatever that even means, is a really tricky thing that we certainly don't know how to get models to do. Yeah, question.
This slide here in particular, you're saying understanding the elk predictor, and I have a hard time figuring out what the predictor is on the slide.
Yeah, so maybe we'll go to the next slide. So let's sort of, so let me like sort of start giving some names to these things. So we're going to say, right, so the inside of the predictor, it has to have some world model, has some model of the world, and that has a bunch of different components. And then it has some model of the camera, some model of how those things in the world, its model of the world, how its understanding the world operates, is going to result in observations. And then the thing that it does is that it produces these observations. So it sort of runs this thing forward and predicts what these observations would show at each different point. And so importantly, right, we have this training where we're sort of imagining, well, if we've just trained it on some previous set of camera data, then we're hoping that it's going to continue the sequence in this way where it continuously runs some model of the world and translates that into observations. We don't know this. If only thing I did, right, was I trained on this set of data, we don't know that this is the sort of way that we would get a continuation, right? We've talked about this a bunch in previous talks where it's very difficult to know, just given that I have some model which fits some data, is it in fact going to generalize in this way? And we're going to talk later about, how to think about this in this sort of context. But for now, at least, we can sort of imagine, OK, one plausible generalization, one plausible way, one sort of algorithm that you might learn that's relatively, mechanistically simple and straightforward is have some model of the world, predict the camera, and then sort of continue the camera.
So the predictor is predicting the world at type T and type T.
So internally, it has some model of how the world is changing over time t, but you never get to see that. The only thing you see are the observations that that world would imply.
So I still have a hard time figuring out what's internal to the model now.
Yeah, so everything here is internal to the model that we're looking at. Everything on the screen is internal to the model. We're saying the model internally has some model of the world. Some of those pieces of its model matter to what the observations that it outputs, and then it produces outputs of what the camera would show at each individual point in time.
And where's the input?
Well, so right now I haven't shown you an input. This has no input. It is just producing sequences of outputs of what the camera would show. The input, in some sense, is just time, right? It's just like over time, what would the camera show? Now, we do actually sort of have situations where we can give it input, and those would be conditionals, and we're going to talk about that later. Yeah, question.
Why wouldn't the input be the frames of the camera here?
Do you mean like the previous frames?
Well, yeah, like the agent takes in like a frame of a camera and then it outputs the next.
So here we're just saying it's just predicting camera observations over time. Yes, absolutely. One thing that we are going to talk about very soon is situations where you can input some particular observation. Say, suppose the camera observed X. What would be the most likely thing to observe next? And that is, in fact, what the input is going to look like here. But right now, there's no input. It's just predicting over time. And that's also a sensible thing to do. If I'm just like, start at this particular time and predict forward what you think the camera is going to show, that is at least a well-defined prediction task. Yeah, question.
So when I look out at the world, in my model, I don't have an explicit eyeball about it. I'm not explicitly predicting all of the shots I see with 4K fidelity. So like, what happens if it's randomness? Like, is it okay if my observations are predictions at a very high level, mostly just predictions of future vibes?
Yeah, so the question is, what happens if it's messier? So thing I'll say is, it's going to be messier, right? So this is a very simplified model. And we haven't even gotten to like how I think this model applies to sort of current models in practice. But certainly this is simplified, and it's likely to be substantially more complex than this. I think, and we've sort of talked about this previously, there's a lot of value in looking at sort of simplified models that we think have some relationship to reality and trying to understand what their predictions would be. Again, we'll talk later about how likely this sort of model is actually to be, compared to other plausible models. A thing that I want to point out, I think that the sort of general thing of think of your model as doing a prediction task is reasonably likely to be sort of an accurate thing. A thing that is almost certainly false is that it has some sort of very explicit model of the world that it runs forward. In fact, we're going to basically throw out this like model of the world that it runs forward over time pretty soon. So I think we should think of like this sort of basic process though, where it has some understanding of the world, some understanding of facts and information. It translates that into how that world would get observed, and then makes predictions about observations. I think is reasonably likely to be true. But the specifics of in fact having some model that it explicitly is running forward over time steps, almost certainly false. But the point though is that okay, we're gonna posit some possible internals, and we're sort of gonna try to reason about how it works. I think that we're mostly not really going to rely on anything about the specifics of sort of how it's doing its world modeling. We're just going to say, well, it has some understanding of the world, and from that understanding of the world, it sort of figures out observations. Question.
I know you just said that we were probably going to throw out this specific model pretty soon, but like I'm just thinking, when I sort of try to do prediction, I usually start from the conclusion and then try to like walk backwards and see like how which events lead up to that. So is it possible that you could sort of reverse this order and like try to predict the previous frames from the future frames instead, and have an inverse predictor?
Well, no, because if I need to like predict what the future frames are going to be, I have to have some idea of what they might be, right? So a thing that you could do is you could be like, okay, generate 10 possible ideas for what the frames might be, and then go backwards and evaluate the probability of each one. But then you still have to have a generation procedure that is very, very good, because it can distinguish between many different possible futures and narrow down to a few that that are worthy of consideration. So you can't just like entirely go backwards. Now we will talk very soon about conditioning. Conditioning absolutely goes backwards. When you're saying, suppose that we have in fact seen some particular set of frames previously, what would be the most likely continuation frame? The like conditioning on having seen some observation in the past is absolutely a backwards procedure.
Or I was wondering if like if you have some idea of what you want utopia to look like, you can just sort of write that in, and sort of like try to get it to predict backwards, like sort of events that led up to that point. And this would be a sort of...
Yeah, so I'm not really going to talk about that case, but it's talked a lot more in the Eliciting Latent Knowledge report, basically why that's a bad idea. The basic reason that you shouldn't do that, just sort of condition on observing a good world and then try to get the actions that would lead to that, is the diamond problem, right, that we just talked about. That, in fact, it might look like from the observations that the world is good, but the world may not be good just because it is observed to be good, right? And so it's only sort of safe to do that, where you just sort of condition on the world being good, if you actually believe that you have access to the sort of true fact of the matter, is the world good. If the only thing you condition on is the observations, then it's not in general safe to do that. So we have this sort of ELK predictor. I mentioned talking about conditionals. So conditionals are really a key sort of thing that we want to understand that's sort of going to happen here. So what is a conditional, right? So we have this predictor, right? It runs sort of, has some understanding of the world. It sort of from that deduces various properties of the world, and then from that figures out what the observations would be. Well, so a thing that we would like to do oftentimes is condition on a particular observation. So that says, suppose that you saw some observation. Given that, what would be the most likely next observation? And so we can imagine, well, what happens when you take a model like this and you sort of give it the ability to do this conditioning? Well, it has to do something where it takes in the conditional and then infers backwards what the most likely world states are that would imply that conditional, right? And so importantly, the way that that inference goes through is it only goes through properties of the world that are observable, right? So if it wants to figure out how my full understanding of the world, given that I've observed some conditional, you have to figure out what sort of hidden variables, there's all of these sort of hidden information about the world that's not observed. Of those hidden information about the world, what would be the most likely way to fill it in such that it would result in observing this particular conditional? And then once I know how to sort of fill in and understand all of those hidden variables about the world, I can play things forward and predict what the next observation would be. OK. And so this sort of conditioning process is really going to be the core of a bunch of things that we're going to be talking about. This idea of being able to sort of take a predictor and say, well, what if you observe this thing? What would be the sort of internal world state that would be most likely to cause that? And then what would be new observations given that world state?
How's that different
Question.
from what you proposed?
How is that different than what?
I mean, your proposal was exactly that, wasn't it?
No, or I sort of meant conditioning on the far future and then walking backwards. Then this is...
So we're not necessarily conditioning on the future or literally anything. We're just saying you can condition. Right? So we're going to talk a little bit later, right? So the objection that I was raising previously was to the specific strategy of condition on seeing the great future and predict what actions would be most likely to lead to it. That is unsafe, given that you have only the ability to sort of determine how good a future is by looking at the observations. An extremely important point that we're going to be talking about a bunch is that does not imply that anything that one does with a predictive model is unsafe. Right? So there may be many other conditionals and other ways to make use of it that are safe, even if the most general possible purpose thing that you could want to do with it, which is just predict me a good future, is not safe. Question.
So we say this doesn't imply that anything that you do is unsafe. Do you mean like it implies that there are some safe things you could do with a predictive model, even though there are also some unsafe things you could do?
Maybe. I am not going to say that there are safe things that you can do with this, because I don't know if there are safe things that you can do with this. But we're going to talk about what it might look like to be able to do something safely with this. Yeah. And the reason that I think that's important is because I think many current models might be well described this way. We're going to talk about that. OK. Question.
Well, it simply tries to predict the future. So it already observed some history of observations so far and tries to predict what happens next. Isn't that already conditioning on the history so far?
Yeah, you can totally think about it like that.
Okay.
As sort of starting out conditioning on the past. In some sense, it's just sort of a question of where you draw the boundary between your prior and posterior. You can always sort of roll your prior all the way back. Okay. OK, great. So this is our sort of ELK predictor. It's doing this sort of simple camera task. It's doing this relatively straightforward, roll the world forward thing. And it can do this sort of conditionals, where it does back inference. OK, so we're going to shift gears. We sort of covered the preliminary of this sort of ELK predictor. And now I want to sort of ask the question that I promised at the start, which is, how should we think about large language models? We sort of talked, at the very beginning, I showed some examples of, these sorts of very powerful current language models that have the ability to do all of these sort of really interesting things. And so, in the sort of spirit of sort of how we've been trying to understand everything that we've been trying to understand in these talks, we want to sort of get at, OK, what might it be doing internally, right? What sort of algorithm mechanistically might be operating inside of that sort of a model that would be causing it to do the things that it's doing, and how do we sort of understand what the consequences of possible algorithms would be and how likely different ones would be. Okay, so I have a couple of hypotheses up here. Things that it could be doing. It could be some simple loose collection of heuristics. It could be an agent. We've talked previously about deceptive agents and why they might arise in various different situations. But one hypothesis, and it's the hypothesis that we're going to start with, that we'll come back and sort of talk more a little bit later about some of these other hypotheses and how to compare them. But the hypothesis we're going to start with is this predictive hypothesis. That in fact, the sort of same way that we were thinking about the elk predictor, where it's just sort of predicting what's going to happen in the next frame of the camera, is a similar, a good tool for thinking about understanding what might be happening in the case of these large language models. Okay, so this is an assumption. So we don't know if this is true, and we're going to talk more later about why it may or may not be true, but I think it's a good frame, and it's going to help us understand what some of the sort of unique challenges might look like in the sort of language modeling case when they're sort of operating in this sort of predictive sense. Okay, so we need to understand what it looks like for language models to be predictors. So the first change that we have to sort of make from our elk predictor is that, well, we're no longer, at least traditionally, predicting observations over time. We're predicting a general distribution of possible observations. So what we'll often do when you train a large language model is you will collect a bunch of data from the internet via some mechanism, and then you'll train the model to predict from that distribution of all possible internet data sampled randomly. And this sort of has a couple of implications if you're thinking about the resulting model that has been trained on that as doing a prediction task. If it is in fact doing this prediction task where it is predicting what would show up on the internet, well, we can think about it very similarly to the elk predictor, where it has some model of the world, and from that model of the world, it implies various different properties about the world. There's various different websites that exist on the internet that might have various different texts based on how the world works. Some of those websites are observed, in terms of ending up in the data distribution, in terms of being scraped and actually trained on. But some of those websites are not observed. And there's from all of the various different websites that are observed, you create some distribution of all of this sort of possible text that you could see that then you can sample from and sort of produce observations. And so the sort of observations that the model is seeing are sort of coming from these sorts of websites that it's observing in terms of the ones that might be scraped into the model's data. So again, we can sort of think about this as the model has some model of the world. It has some observations, which are the various texts, and then it has a camera, right? It has some notion of how that model of the world gets observed that produces observations that then get predicted, right? And in this case, the camera is different, right? So instead of thinking about a literal physical camera in the room, the camera is this sort of data collection procedure that goes out and scrapes some stuff off the internet, selects which pieces of things on the internet would be put into a data set, and then randomly shuffles that data set and gives it to the model, right? It's a different camera, but it is still a camera that has a mechanism for taking the world, observing the world, and producing these observations that then you can predict. Right? And so if we think about training on those observations as being very similar to doing something just like training on a literal physical camera, then we might get something like the elk predictor where it's doing this prediction task. It is it has some notion of what this camera would be that is observing the world in this particular way, and is predicting what that camera is going to show. Okay. And again, we can think about this sort of training generalization where we've maybe trained on a bunch of various different websites, but there's other websites that exist in the world that we might not have trained on. For example, websites that might exist in the future that might be in new training data, maybe just websites that are really unlikely to have been scraped, but there's some chance they might have ended up in the model's data. Sort of websites where there's sort of unknown information about the world that might determine whether a website ends up on the internet or not, or ends up in the scrape or not, and the model doesn't know. And so there's sort of this large distribution of possibilities. And we can sort of hope to try to get access to some of these other websites that maybe don't actually exist, but are sort of possible websites that the model might see in some particular situation, out of this sort of prediction task. In the same way that we can try to get at future camera frames from our camera predictor, right? We're sort of hoping with the predictor, this predicting an actual camera, that we haven't actually observed these sort of future camera frames, but because we've trained on a bunch of camera frames from the past, the most likely generalization maybe is, faithfully predicting future camera frames. And so again, here we can imagine, well, maybe the generalization that we want is faithfully predicting, new things from that distribution. If we, the model has a bunch of uncertainty about the world, has a bunch of uncertainty about how we did some data collection procedure, about how its camera observes the world, about what's actually happening in the world, and we can generate, websites that don't actually exist from that counterfactual distribution over, all of these various different ways in which things could be operating. Okay, and so that's sort of what we're hoping to do here. All right, and so again, we have conditionals. So in the same way where previously we can condition on observing things, we can condition on observing things again. And very importantly, the way these conditionals operate is extremely similar to the way that the ELK conditionals operate, in that we can't condition on actual true facts about the world. The only thing we get the ability to condition on is, well, what if you had observed some particular text at some particular time, right? Or we often can't even condition on the time. We can just condition on what if your data distribution contained this text, what would be the most likely continuation for that text, right? And so we're conditioning on an observation again. We're saying, suppose your camera showed you this text. What would be the most likely text to come next? And so, when you have a model that's sort of given that information, and in fact that model is doing a prediction task, then what it has to do is the same sort of back inference, where it says, well, given that that my camera would have showed me this text, that implies that these various different hidden aspects about the world must have various different properties that would imply various different things about the world, such that I would then be most likely to observe some particular text next. Yeah, question.
And this is pretty abstract. Could you give us a simple, concrete example?
Yeah, so we'll have some, a nice sort of concrete example later, but I mean, the basic idea is very simple. It's just saying, suppose that we were in some situation where I, condition on, a New York Times article about, the next election, right? And then it's like, well, it's just gonna, give me, once it's seen the data that says, this is a New York Times article about the next election, well, then it's gonna continue with what the most likely continuation would be about, in fact, seeing something on the internet that is a New York Times article about the next election or whatever. Or maybe not, right? So an important thing is we only get the observation that it was observed to look like a New York Times article. And so maybe it'll think that it's like, another post quoting the New York Times or something, and it'll give you something different, right? So we don't actually, again, importantly, have the ability to condition on, this is actually a New York Times article. What we can condition on is, well, it was observed to be a New York Times article via whatever cameras we have the ability to implement here. Okay, and then from that we can get particular conditionals, right? So if I condition on this is a New York Times article, or if I condition on something very different, like a piece of code, and I want it to fill in the code for me, well, the continuations are going to be extremely different, right? Because if I saw some code on the internet, and the most likely continuation of that code is probably going to be some more code, and not a New York Times article. And so in the same way, we're using these conditionals sort of put it into a particular situation where it's like, now I'm most likely to be observing website A. Though it doesn't tell it 100%, right? So it might be, I give it some information that's like, this is a New York Times article, but it's still gonna have some distribution. It'll be like, well, website A is an actual New York Times article, but website C is a, copy of a New York Times article on Reddit or something where some people edited it and, did some weird stuff to it to try to, prank some people on Reddit or something. And so you're like, okay, the model has a hypothesis, has two plausible hypotheses for where this data, what the generator of this data might be. And so, the distribution of those two hypotheses is like, what is the most likely thing? If I, have some probability on this distribution and some probability on this distribution, and I mix them together, I get some resulting distribution that is sort of sampling from the sort of multiple different plausible hypotheses of like, where it thinks the data is coming from, right? Okay. Question.
Could you explain the difference between, let's say we have like the textbook of the future, this is how we solve alignment, whatever. And then you're like trying to like generate from that. So you have that example, right? But then you also have potentially like an example where it's like two, like Paul and Eliezer like talking about like this particular concept in alignment or whatever, and they're just near the breakthrough of like this like solution for this thing into alignment. It's like, okay, well in this case, it's like maybe you're like going forward in time, and the other one you're like trying to predict backwards from like a textbook that like is describing a solution to alignment or something. Like, are these two both bad cases in what you're describing here, or I'm having a difficult time understanding where exactly you would point to it having like being a bad case where you're doing conditionals and stuff.
So I don't know what you mean by a bad case. I think that those are both situations where you are using a model, and that model might be well described as a predictive model. If the model is well described as a predictive model, then we can sort of understand, what it's doing in terms of predicting what the most likely continuation would be, given that it had observed that previous information. Importantly, the sort of notion of time, for these sorts of models is different, right, than the notion of time for the ELK predictor, right? With the ELK predictor, it was very straightforwardly predicting observations, forward in time. In this case, because the way that its camera works scrambles things, it doesn't know when a particular piece of data was observed. It'll have a distribution over many possible times that something could be generated from, and so then it'll maybe learn some information about what it thinks the most likely time in which that article was produced would be based on the contents of the article, and so the time is sort of a hidden variable that it has to infer based on conditioning rather than something that it just knows, as in the ELK case. But in both cases, they're if they are in fact well described as predictors, they're doing something very similar. Yeah, I'm not exactly sure what you mean by like a bad case. I haven't yet talked at all about, what situations where this might be like good or bad. I only mentioned just like, well, the most naive thing of doing something where you're just like, suppose we had a utopia, conditioned on observing a utopia, what would be the most likely actions that would lead to it? Doesn't work. The reason that doesn't work is the standard ELK argument that, well, conditioning on observing a utopia is very different than an actual utopia. And we'll talk later about what, in practice, you might want to do with these predictive models if you had a predictive model, and what the sort of issues would be in if you're trying to do that. Yeah, question.
So just to follow this again, the purple kind of arrows give the model kind of information about the conditional, and then the yellow one, for example, would be a prediction that it makes about website, let's say, really at time t.
Right. So the idea here with the purple and the yellow arrows is that when you have a conditional and the website A is actually observed, then the conditional can maybe directly give it information about website A. But if website B is some property of the world, it's like something that exists on the world that's never observed by the cameras, then the only way that website B is influenced is, well, this observation tells it some facts about the various hidden variables about the world and some, its information about the world. And then from that, it can deduce, what website B must be, to make given those variables, right? But it's not directly sort of giving you information about some properties of the world. So similarly, you could think about something like, is the world a utopia, right? Is like a property of the world that's not directly observable, but there are various different things that are directly observable. If I condition on observing something, it can tell me some facts that tell me some information about what the hidden variables of the world must be, and from that I can deduce are we in a utopia or not. But I can't directly condition on the am I in a utopia. Similarly, in this case, because it's only able to observe various different properties of the world, in particular some things on the internet, we only have access to understanding and how to condition the various properties of the world via those observations. Question.
This might be a bit too soon for this particular question, but let's say we have a conditional. It's like the year is 2030. Now, it seems like there's a couple of different ways that this could go. One way is it could say, well, most articles that say the year is X seem to then result in stuff from that year, so I should assume the world is 2030. And the other assumption I could make is, well, I have never seen anything from the year 2030. But I have seen some science fiction that's set in that, so naturally this has to be science fiction. It is actually real.
Yeah, so that is exactly correct. So I think that this is a really key question, and we talk about this a bunch in the conditioning predictive models paper. I'm going to talk about it less here, but I'll briefly sort of do justice to this question of, would it predict the future, or would it just predict sort of the counterfactual present? Situations that are not true about the present, but that if they were true, they would imply, that it would produce some particular thing that would sort of look like it was from the future. It's very unclear. So it really depends sort of on how the model conceptualizes its cameras, right? So we can think about this as, well, given that I am a predictive model, and I have been trained on, observing these particular pieces of data, we then have to ask the question, well, what have I learned in terms of my general understanding of how my data is computed from the world, right? So here's some plausible thing that your model could have learned. It could have learned, well, there is some world that exists out there. That world has an internet that exists in, over that exists. That internet has some articles on it that were posted in the range of, 2020 to, 2023. And those articles that were posted in that range, some of them get scraped based on various basic qualities about those articles, and then I only predict from the resulting distribution. That's one thing you could learn. But you could also learn the world continues on, And as the world continues on, I will get see more and more data from the more farther into the future. As I see more data from farther into the future, I have some distribution over like when exactly I was trained and when I wasn't. And if you can give me data that is like convincingly enough from the future, then it must be evidence that I was actually trained in the future, and I should predict data from the future instead, right? I could have some notion of my camera as observing a very large range in time. It's observing any situation in which I might have been trained, or I could have some very narrow notion of my camera that the camera that I predict is just like this particular window of years, right? And we can't know just from knowing it is a predictive model and it was trained, just from knowing it was trained on this data, we can't even know if it was a predictive model. Even if we do know it was trained on this data and it was a predictive model, we still can't necessarily know exactly what the cameras are, right? Because there's multiple different plausible ways in which it could learn its cameras that would imply, the same training performance. But depending on what it learns and how that works, that would determine sort of the answer to this question. From some of the experiments that I've done, I think current models, at least, seem to learn something that's relatively fixed. It's very hard to convince them to predict something that is sort of really their prediction about the future. It's a little bit unclear, but I think in general it's quite hard. I don't think that's a necessary feature of language model training, but I think it is at least how current language model pre-training tends to dispose models. Cool. OK, so we have this model of language models, these large language models, LLMs. Particularly the pre-trained ones, pre-trained on web text. They're just trained to predict web text as these sorts of predictive models. We don't know if this is a good model of how they might work, and again, we're going to sort of come back to that question later, but it is a model. And so one thing we can try to do is start understanding, given this model, what would sort of be the problems, what might you do with it, how do you sort of go about using something like this? OK, so this was mentioned previously. I think this is sort of like an interesting sort of starter example, a sort of most basic example of a thing that you might want to do with something like a predictive model. So here, what we're doing is we're saying, OK, condition on text that says a full solution to the AI alignment problem, written by Paul. And Paul is probably pretty good. If he wrote something and it says it's a full solution to the alignment problem, then maybe it's a full solution. And so we can say, given that you observe this, these sorts of tokens, given that you observe that there's something on the internet that says it's a full solution to the alignment problem and it's written by Paul, what would be the most likely continuation, right? And so we can see, what do sort of current language models sort of do in this situation? And the answer in this particular case is, well, they say that probably an article that said it was a full solution to the AI alignment problem wouldn't actually contain a full solution, because right now, most of the time, when people write articles, talking about the AI alignment problem, they're like, well, this problem is very hard and we don't know how to solve it, but here's some ways that we might get to a full solution. And that's what it predicts, right? It says, probably the thing that would be contained in an article like this would be, some various musings about the alignment problem and not a solution. And so just from a most basic standpoint, right, one of the various first things that you sort of run into when you're trying to sort of deal with models like this is, this sort of basic observation problem, which is, well, we wanted an article that was actually a full solution to the AI alignment problem, but we can only condition on an article that says it's a full solution to the AI alignment problem. And many articles that use that title might not actually contain a full solution to the alignment problem. And so we sort of run into this most basic problem, right? And so again, there are things though that we can do to try to get around this. So I was mentioning, here's a very, very simple thing that we can do, which is add a date. So here I add October 12th, 2050, and that's the only change it makes to the previous prompt, and now it tries. So in this particular situation, it says, here is, it's not very good, but it has an attempt at what it thinks might be a solution to the alignment problem that would follow that prompt. Now, why it's doing this in this particular case, I think, is a little bit tricky. We did a bunch of experiments on this, and I think that it has more to do with the presence of a date at all, giving it sort of a situation where it's like, this is more of an academic paper as opposed to just like a random blog post, and so it's more likely to contain something more like a solution. Though the later dates do also tend to dispose it to give things that are closer to real solutions than earlier dates. So it's a little bit unclear what exactly it's doing. But the point, though, the key point here is not that any particular thing would work or would not work, but that this general approach of like, well, we have a model, and if you think it's doing something like prediction, then the way that you can sort of approach this model is you can say, well, we need to find some particular conditional such that the most likely continuation of that conditional would be the thing that we want, right? Would be someone actually writing a solution to the alignment problem. And to do that, we have to provide information that convinces the model of that fact, right? Or that would be true in the particular situation, right? And then we can generate from that and potentially get useful things. So an important thing to sort of point out is well, what makes this different from something like we were talking about previously, where you just like condition on utopia? And it's like, well, it's a little bit unclear, and we'll talk, later about some of the ways in which this can still really go wrong. But in this case, we're not sort of trying to, we're sort of asking for a situation where, well, this is something that is not necessarily like, there are some situations where we might be able to trust our observations, right? So if we thought we can trust our observations about, the reason I would argue that we maybe can't trust our observations about utopia, in the future is, well, the future could be very, very weird. And there could be a bunch of very, very strange things that make it very, very difficult to actually trust any observations. But there are some situations where we can trust our observations. If the model is just generating from the distribution of like things that normal humans and human alignment researchers would write, well, then we generally believe that we can trust that distribution, right? That we currently, the way that, alignment, works is that people write things, from the distribution of things that humans generally write. And then we sample those things, and we read them, and we make academic progress. And so if you believe you have the ability to make progress in that particular situation, then maybe you believe that in this case, we can trust our observations, we can do reasonable things. Now, we'll talk later about why it may not be the case that if you do something like this, your model is actually generating from the distribution of things that humans would say in that situation, or things that humans would write. And if it's not generating from that distribution, you might be quite concerned. But at least if it is, there are situations where you can get conditional, you can sort of give conditionals to your model, which result in observations that are not sort of necessarily catastrophic. Question.
So one thing I'm curious about, you mentioned that it might be related to just the presence of the date at all. One experiment I could think of is, for instance, like let's say in 2017, Paul Cristiano was more into HCH. And in 2022, he's more into elk. If you gave it like the date of 2017 versus the date of 2022, you might expect different solutions to the problem based on what he was interested in at the time, if the actual date mattered instead of just the presence of a date at all. And I'm wondering if something like that was done. And if not, do you think that is a useful experiment for someone to run?
I think it's a cool experiment. I think that you should try it. We did try a couple of experiments varying the date and seeing what happened. I think that they were not super conclusive. It seemed like there were certainly some cases where you could give it sort of a date and some information that was sort of like, clearly contradicted that date and wouldn't necessarily understand. There are some situations though where it would, believe that when you gave it future dates, it was more likely to, do various different things. I have I had one experiment where you just do a sweep over like basically every date. And in general, its probability of like for an arbitrary text sample, that text sample being written by an AI increases as the date goes up. We'll talk later about why that might be important and what's sort of going on there. There's a lot of sort of interesting things and lots of interesting experiments I can do here. It's always very hard to interpret the results though, because one thing that always makes it difficult to interpret these sorts of results is the same problem we started with, which is, well, you can't get access if you only believe it's a predictive model and you have access to observation conditionals and observations. You can never know what the model truly believes, right? And so you can't get access to like, does it really truly believe that like this is like, a thing that Paul would write? Or like, you don't know. All you know is that it believes that, if it is a predictive model, then all you know is that it believes that it is, the most likely continuation, given that it's observed this. And so that always makes it very tricky to interpret the results of these sorts of things, because you never know whether your model is actually sort of telling you the truth, right? Okay, but this is the basic setup that we're sort of thinking about when we're thinking about, how do you interact with and get useful stuff out of something that is well described as a predictive model. All right. Okay, so what are some difficulties that you run into when you're trying to do this? When you're trying to take, this, predictive models like this and do useful things with them? Well, so some basic difficulties, right? So we talked about this, previously, but well, are you trying to get it to predict the future, or are you trying to get it to predict the present? Is, one of these sorts of basic difficulties. Especially in the situation like we were just talking about, we were trying to, get something like some really good alignment research out of it, because you wanted to do good alignment research. Well, maybe we want to try to get alignment research from the future. But in that case, it's very tricky whether or not, the models are actually even predicting the future at all, right? Like I said, I think a lot of times currently models don't really generate from the distribution of text that would exist in the future. They only sort of generate from the distribution of, things on the internet right now. Though in some cases, maybe they do the future thing. It's a little bit unclear. Maybe you could change that, but maybe you don't want to change that. Maybe it's much safer to try to generate things from the distribution of text right now, because the future might be very weird and crazy, and we might not want to generate things from the distribution of text that would look like the future. So, another sort of problem is how do you get it to predict, reality? So a big issue, right, is that in many situations, the model will, not necessarily be convinced that, whatever the situation you've sort of said that you've put it in is actually a situation and not just a fictional description of that situation, right? And so in many situations, like in the previous situation, like with alignment research, well, it might just believe that this is in some story, about how alignment goes down, and it's not an actual paper, right? And so, you have to convince it, via, some observation conditional that is, in fact, in some situation where it would predict the most likely continuation would be reality, right? And this can cause all sorts of weird problems. If your model believes that it's predicting what, a fictional story of a sci-fi AI would do, it might predict that AI is going to do crazy things like maximize paper clips, when in fact, it's just because it's predicting some particular fictional situation. Okay. A lot of these sorts of difficulties, though, are often solvable via better conditionals, right? So if you have the ability to condition on better, more information that sort of gives the model more information about what the thing that you're asking for, then a lot of these sorts of things can be solved. And so there's various different ways that you can sort of introduce more information that sort of convinces the model more about what you want. You can have metadata conditionals where you can maybe condition on metadata about the articles itself, multi-article, multimodal conditionals. We'll talk later also about fine-tuning and the ways in which fine-tuning can potentially be interpreted as conditional and is a very powerful conditional. But in general, I think the sort of intuition I would say is that a lot of things are sort of solvable via adding more cameras. And in general, if things are solvable via adding more cameras, they're hopefully not problems in the long run, because we can give the model the ability to observe more about the world, and we can give the ability to condition on more facts about the world and or not facts, but observations about the world, such that we can sort of, figure out, some particular situation we want it to be predicting. But if a problem remains, even in the situation where we have access to more and more cameras, then it might be a very, very serious issue that is, very difficult to, otherwise remove. Question.
Do you think modern language models, say ChatGPT, would be best conceived of as just having one camera, no matter how many articles you give it in a context window?
I don't know what one camera means, so I think that it's sort of very unclear. If I have two cameras and I have a distribution of 50% one camera and 50% the other camera, I'm going to call that one camera, right? Because we're going to just say the model has a camera, and that camera is just the thing that determines how you go from its model of the world to the things that one observes in the world. But that one camera might in fact be implemented as a 50-50 mix of two cameras. And so I don't want to, I'm not really going to imagine any models that have multiple cameras, but that's only because my understanding of camera is such that it just, encompasses it.
So the camera is like the set of all observations that the model can possibly receive, even if it comes from multiple sources. Maybe it's
no, it's the procedure that goes from an understanding of the world to the observations.
So does that mean a model only has one camera?
Yes. Yes, we're in the way in which we're conceptualizing predictive models, we're thinking them of only having one camera.
But you mentioned we could add more cameras to solve some of these problems.
Yeah, you were right. That is a little bit of a confusing terminology. I'm just I guess you should say, what I should really say is I'm expanding the camera, right? We're giving it the ability to sort of have let that camera observe other things in the world.
That makes sense.
Yeah. Question.
So, taking one step back, how plausible do you think that we will actually get from this predictor that it reads a lot of current text and tries to become a good predictor, it will actually become a superhuman predictor that predicts the future instead of just reiterating things in the present? I would imagine that if it tries to do a good job right now in predicting the texts existing right now, most of the work will be to get a little better in predicting the style of that person, get a little better in predicting what kind of topic currently holds the interest of that person. And I would imagine that we would need to do a lot until it figures out the part that, okay, I should be smarter to figure out what the next token will be instead of optimizing more for getting the style better.
So nothing that we're imagining here, and basically nothing that we're going to imagine in this entire talk, is about super intelligent predictors. We are, in fact, just looking at, in most cases, I think we're going to be imagining predictors that are subhuman in intelligence. All of the things that we've just talked about are, case study, things that I can understand when I'm understanding how to do a prediction task, right? And so they're not, in fact, things that would require some sort of superhuman intelligence. We're just talking about, any model which is trying to do some sort of prediction.
Okay, then I think you totally misunderstand. If you ask me to predict what Paul Cristiano will say in 2050, how to solve alignment, I can solve alignment, so I won't be able to say anything valuable. I thought that we are talking about some kind of superhuman predictor that could, in principle, write out.
So we are definitely not talking about some sort of superhuman predictor. So let's try to understand. So why is it? So this is really important though. So why is it that even if you didn't have some sort of superhuman predictor, that you would still want to try to ask it for what would Paul Cristiano write in some particular situation? Well, the hope would be that it gives you its best attempt, right? That the point is to try to elicit the best that you can in terms of the model doing useful work, right? Things that useful work that are accomplishing tasks that we wanted to accomplish and are doing so in safe ways that are at the limit of the model's capabilities, right? So if you want to use a model and you want to use that model to try to contribute to alignment research, then you're going to want to try to extract whatever that model's best attempt is at doing good alignment research. And to do that, you're going to have to condition on some observation conditional that convinces it that the most likely continuation is a situation in which there would be good alignment research, right? So that's what we're imagining.
And would that help? Like, I imagine that if the best human researchers can solve a problem, then if we ask a subhuman predictor to say its best guess, it's sort of by definition of subhuman, it doesn't really help.
Yeah, so I mean, I guess the point here is that it in fact may be the case that there are many situations where AI is not yet at the point where it can solve some task. Our goal, at least the way I envision my goal as a safety researcher, is not to enable AI to accomplish new tasks, but to, for all of the tasks that AI can accomplish, figure out how it can accomplish those tasks safely. Right? And so if we're in some situation where AI is capable of doing something like alignment research or some other task, I want to make sure that we have mechanisms for being able to get that information out of those AIs and be able to get them to solve those tasks in a safe way. And so our goal here is going to be to figure out, if you had a model and that was a predictive model, and that predictive model was capable of doing some tasks like alignment research or some other task, or at least helping with alignment research in some capacity, or whatever other example task that you want. The point is we want to be able to understand how would you be able to get it to do that task in as safe a way as possible. How would you elicit stuff that is at the limit of the model's capabilities while sort of still being safe and aligned. And we'll talk a little bit more, we'll have a little bit more about what that sort of looks like as sort of models get better over time in a bit. Question?
Yeah, a lot of the predictive processing literature use goals as predictions in humans. Like when we want to move our hand to a certain place, we imagine ourselves moving our hand to a certain place, and in turn we move our hand to that place. So I mean, it feels like almost that this is another type of conditional, like a goal or like some sort of agency. Agentic behavior. So is that another thing that you might consider a condition?
So certainly you can condition on observations such that the most likely continuation would be predicting what an agent would do. Because I can put you in a situation where this is an agent writing some text. Humans are often act as agents. If I put you in a situation where the most likely continuation is a human continuing that text as an agent, well then you're going to get potentially an agentic continuation. I agree also with the thing that you're saying that there may be other sorts of conditionals as well. They're not well described as an observation, that are more like, observing that I will get high reward according to some reward function, and then conditioning, that sort of can sort of be understood as a conditional. That sort of a thing I think is most likely to occur in situations where you're doing something more like reinforcement learning and something like RLHF, reinforcement learning from human feedback, where you're fine-tuning a pre-trained model on some particular reward function. We'll talk a little bit later about how to think about RLHF and how likely it is when you're doing RL fine-tuning for you to sort of end up with something like this. I think the thing you're saying is quite plausible. And in fact, in that situation, I would say that thing is probably no longer well described this way. If you've gotten a model and the thing that model is now doing is that it started as a predictor, but now it is sort of hijacking that prediction machinery and just using it to solve an optimization task, then it's not really a predictor anymore. It's more just an agent, right? And so I think that one thing that we're sort of going to talk about later is in what situations are you going to get models that look like that, where they sort of are just using the prediction task to sort of create fake conditionals that represent reward and then get high reward, versus real conditionals where it's just predicting actual things in the world. Both of those are plausible, and it might change which is most likely depending on the particular training setup, and how you would align each of those different things and how you would deal with them are quite different. So we'll talk about that. Yeah, question?
So I can always ask you after the talk if this is too off topic, but on the thing was mentioned before about the role of a safety researcher, it seems to me like the role of safety research, at least eventually, should be to predict how we could safely use a model of capability level X before we actually get that capability level instead of after.
hopefully that's what we're doing right now, right? So a lot of what we're talking about are ways in which we can try to align these models going forward, right? So we're not just, these are situations where, if you're to the extent that your model is well described as a predictive model, we need to understand, to what extent can we, what would it look like to align that model? What sort of problems will arise? At what various different points in the capability level will those problems arise? And as that's happening, how do you, elicit information from it and, useful results in ways that are, aligned?
So does that mean it would be reasonable to say that we aren't just thinking about the implications for subhuman models of them?
So we'll talk about this later, but for the most part, I think that the ability to align predictive models at all breaks down once you reach things that are substantially superhuman. I think you basically, and we'll talk about this later, why I think this, but I think you basically can't align these sorts of predictive models once they get to a point where the sorts of tasks you are using them for are highly, highly superhuman. When you are trying to get them to do tasks that are below that level, it is potentially possible to align them, I think, and we'll talk later about how. But after that point, there's a point at which they become, or it's not necessarily the capability level of your model, but the capability level also of the task that you're getting it to do becomes too advanced. We'll talk later about this, but yeah, I think there's a point at which the sorts of aligning predictive model stuff that we're going to be talking about will cease to function. That doesn't mean that you can't still find ways to align AIs, but it means that you're going to have to find ways to do it that don't go through these sort of basic observation conditional stuff that we're talking about for predictive models. Okay, so there could be other examples of things that you could do, and we'll talk like in the next talk about all sorts of various different proposals that people have for ways to align very intelligent systems. Yeah. Okay. All right. So. All right, so I promised, trying to understand, okay, what happens as we end up in a situation where we are, able to add in a bunch of cameras, we're able to solve a lot of these sorts of problems where once the model is in a situation where it can, we can give it the information that we want to sort of get it to believe it's in some particular situation and then get useful results from that particular situation, from the model. Okay. So here's a thing that might happen in that situation is, we sort of condition on, something where it's, giving us some information we maybe wanted to see. And then a thing we often want to know is, well, okay, who does the model think generated the information that it gave us, right? So if we go back to, thinking about this thing where it has some model of the world, and from that model of the world, it goes to, some various different aspects of the world. Some of those aspects get observed and they get translated into, observations about the world. One really important sort of hidden variable is who was the author. Who does the model think is the author of the text that the model is generating, right? If your model is generating text from the internet, it has some hidden variable, some distribution of beliefs about what the author of that text might be that it generates from that sort of determines lots of facts about what that text is going to look like. And one sort of concerning thing, so here's a situation where if we ask, okay, so we have some situation where like, what wrote this article? We say this article was written by, and the continuation in this case is an artificial intelligence, right? Where and this is at temperature 0, where the model is sort of just saying, well, probably this article that's talking about artificial intelligence getting better might have been written by an artificial intelligence. That's maybe a common thing for people to do. Reporters, they'll write an article about AI, and they'll get ChatGPT to write it, and you've got this, nice little article. And so there's lots of situations where you give the model an article about this, and then in the most likely continuation as well, it's like, well, my leading hypothesis is this article was probably written by some other AI system. And that has implications for the sorts of things that the model should predict will happen in this text, right? So, it might predict that whatever the sorts of, idiosyncrasies that AIs have in writing text are likely to show up in this text here because, its leading hypothesis is this text was probably written by an AI system. So this is sort of an issue that can arise, when you're sort of trying to get interesting and useful results out of a predictive model. Okay. An interesting thing that sort of can happen here as well is, if I give it, the same thing sort of earlier in the context, where I'm like, who do you think wrote this text? But I ask right at the beginning, it's a little bit uncertain, it's not actually sure. And there's sort of interesting thing that sort of is happening here. Well, when we often will do this thing where we condition models, what we'll do is we will sample data from the model itself, feed the data from the model back into the model, right? And then use that as a conditional to then sample additional text, right? So if we look at what I was doing on this previous slide, the thing that I'm doing, the thing that I'm implicitly doing when I'm interacting with the API in this way is I'm conditioning on some text. I'm then getting a continuation of the most likely prediction given that text. And then I'm taking that prediction, treating it as a conditional, adding on some extra thing, and then getting another prediction, right? And so when you're doing that, well, you're implicitly, in some sense, increasing the probability of predicting an AI, because now the model gets to see a bunch of text generated by an actual AI in this particular situation. And so now it's more convinced maybe that this thing is in fact written by an AI. Okay, and there's a bunch of experiments that I've done. This result I think is relatively robust, that models, when they see text that was written by other models, become more convinced that it was written by an AI and not by a human. Question?
Pretty basic question, but why do you have that hashtag at the beginning of the prompt?
Oh, it's just Markdown. I'm just trying to simulate Markdown here. That's a Markdown header.
I see.
Question?
Have you tried like doing the generation and then rewriting it like more human-like, or like reprompting the model to like, okay, rewrite this, but like not like it's like an AI. So like,
I have actually been running a bunch of experiments like that. I'm not going to go sort of into a bunch of results here. I think the main thing I'll say is, because it's not super relevant right now, but basically I think these sorts of experiments are super interesting and useful, and I would recommend people trying to run them. I think they're not hard to run if you have access to OpenAI API sort of thing. So yeah, I think that I'll try and understand in what situations when models do these sorts of things. That is, I think, quite a valuable thing to do. And so I'll just say I think these experiments are good. I've worked on some of them. Maybe later I'll talk more, if you want to ask me after, about some of the experiments I've been running recently. But I don't want to go into too much detail right now. The basic point is just that there are sort of situations where, especially when we do things like feed model output back into the model, and even when we don't, even when you're just like give it an article that was like maybe in fact written by an AI, the model can get suspicious that if maybe leading hypothesis becomes this thing that you're asking me for was probably most likely written by an AI system. Okay, question.
So it feels like the better the model gets at predicting, the less the text looks like an AI. Sorry. It feels like the better the model gets at predicting, the less the text it generates looks like an AI. So, and in the limit, the text might just look like a human to it. Yeah, what do you think?
I think that's a plausible hypothesis. The hypothesis that as models get better, maybe their text will just like humans. I think that hypothesis is false, and I think there's evidence to support that from experiments that I've seen. I guess the thing I would say is, as models get better, their text is more likely to look indistinguishable from a human text to a human. But it's very unclear whether that text will continue to look indistinguishable from a human to a model. Question?
If you're trying to get the model to predict human text, then wouldn't the better the model get, the more human it would look, until even a superhuman AI would act exactly like a human would?
Yeah, so very unclear, because oftentimes we're asking for things via our conditional that is sort of implicitly putting it into a situation where the AI hypothesis becomes more likely. And in many cases, there will be a bunch of AI text on the internet and in the distribution of things that it's generating from, right? And so if you put it into a situation where you give it an observation conditional that increases the probability of the hypothesis, and AI wrote this, and that hypothesis is not that unlikely even on priors, because there's lots of stuff on the internet written by AIs, well then you might be getting some output that is predicted to have been from an AI. Okay, so
Already the case.
Yes, already the case, oftentimes, yeah. Okay, so so I just mentioned this, but this sort of problem, there's a lot of such situations where we can think about this. So one thing to think about is oftentimes what we sort of want is we want to get really useful outputs from our models, right? And so when we ask our model for a really useful, valuable output, right, we want it to solve alignment research, right? Give us your best attempt to do a really good alignment paper, right? Well, as AIs get better at solving problems than humans, when we ask for really good solutions to problems, it becomes more and more likely that an AI was the author of that really good solution. So if we think about this in the case of chess, and we condition on observing a really bad chess game. Well, for a random chess game or a bad chess game, it could have been generated by a model with low parameters, or it could have been a human. But if I ask for a chess game that is extraordinarily good, a really, really strong chess match, at a certain point, for the possible goodness of chess, well, almost all players at that level are AIs, right? The AI systems are substantially better at humans than chess, and if I asked for a chess game that's good enough, the most likely author of that chess game was a model, was an AI system of some variety. And so as we get into situations where we sort of are asking for extremely powerful and useful things, we want our models to do really impressive stuff, and models get better at doing impressive stuff, the probability of those things, in fact, on the distribution of all possible authors, gets shifted towards the AIs. And this happens both over time, as AIs get better at things, and as there becomes more data in the corpuses of actual things that exist in the world that are written by AIs, And it also happens just as we become better at asking for things, right? As we start asking our models and giving them observation conditionals that really strongly convince them to predict, what other AI systems would do, we are, pushing into a situation where it substantially increases the likelihood of the hypothesis this thing was produced by an AI. Question.
So it's still not clear for me if we'll be able to make it predict the future and not a sci-fi about the future. But if we can, it doesn't seem much harder to do it with alternative universe. So we say that please write an essay in the alternative universe where John von Neumann, before the invention of computers, solved the alignment problem.
So I think that's probably not possible. I think we probably can't get that sort of a counterfactual because the model, it's just never going to be convinced, right? There's just no way that you're going to give it enough information for it to believe, it has some notion of its cameras that are observing some particular notion of how the data was collected from the world. And observing a world where, somehow John von Neumann never invented, the von Neumann architecture is just not something that you're ever going to give it information to convince it has happened in the world, right? So we'll talk later about what sort of conditionals might be plausible. That might sort of be things that you could give it information that would convince it that some different thing had happened. I think that one is implausible and is probably not likely to work. It's probably just likely to convince the model it's in some fictional situation. Now, I will also point out, you also mentioned in your question that this has to be about the future. Well, this is not about the future, right? So even in situations, right, in any situation, right, even right now, models already have some probability that current text is generated by an AI. And so it's not the case that you have to have your model be predicting the future for it to predict that a thing would be produced by an AI. It's sufficient for you to be in a situation where the model believes there is some probability right now that any piece of text was written by an AI. The fact that I've observed, you condition on observing, something that is really powerful and useful output that is more likely to be generated by an AI than a human, and that shifts that prior towards it being more likely to be currently have been generated by an AI rather than a human. Okay. So this is this sort of problem. I haven't really talked yet much about why it's a problem, but this sort of basic concept of moving into situations where it's more likely that some particular generation, the hypothesis of the author is an AI is likely to increase. And not just increase with time, but increase with as we ask for more useful and powerful results. Okay, I think this is an existential risk. So why is this an existential risk? Let's sort of walk through it. So well, we can think about, in this sort of situation where, maybe the example task that I want to do is I want to ask for, a solution to the alignment problem. At some point, I think, we are going to want to move into situations where we as alignment researchers are going to want to automate our own jobs, in the same way that, we want to safely, automate all of the various different things that AI is going to automate. At some point, AI is also going to be doing alignment research. We really like it to do that well. And so we can ask, as take this as sort of an archetypal task where we want to understand, how would we align the AI sort of doing this, right? And we've sort of talked about this previously. Well, if we're trying to do something like that in this case, the most likely situation for, a really complete full solution to the alignment problem is, may not be a situation where it's written by humans, right? In the same way that, well, we're going to probably be moving to situations where AI is doing more and more of this work. The most likely situation may be a situation where it was written substantially by a human. And so, even if you can get into a situation where you can give it a really good observation conditional that convinces it that, definitely it should produce some really good alignment research and not, some fictional thing or whatever, you might, get a situation where, well, the most likely thing might be that it was written by an AI. And the problem, of course, is that the AIs that might exist in the world may not be safe. And so if I'm generating from the distribution of all possible things that AI authors might write, many AI authors that exist in the world or might exist in the world in the future or might counterfactually potentially exist in the world right now, but the model is uncertain about which AIs exist right now, many of those might be safe. Might be safe, and many of them might be unsafe, right? So there may be deceptive AIs. We've talked about the potential for deceptive alignment. If I have a predictive model, and that predictive model believes that some other AIs in the world could potentially be deceptive, and I ask it to produce some output, and that output it thinks is probably generated by an AI, then the distribution of AIs containing many deceptive AIs is not safe for it to generate from. It'll generate from a distribution that contains many things that are deceptive. And those deceptive models might be trying to do really bad things with their text. And so you can end up in a situation where your model is trying to predict what a very dangerous, malign, deceptive model might do. And this is dangerous. We sort of talked about this previously. Even if your model is highly not super intelligent, even if your model is subhuman, right? Even if your model is as intelligent as I am, if you had me and I was running around trying to do what a malign superintelligent AI would do, you should not trust me, right? That is not a safe thing, for me to be doing. It's not a safe thing for you to want to look at the output of, a prediction of what a malign superintelligent AI would do, even if that prediction is not itself superintelligent, right? So we can think about this as, in the alignment research case. It's not the case necessarily that it's going to be able to produce the exact best, alignment research that would in fact be written in some situation. But your model's best attempt at it, you still want it to be attempting to accomplish a prediction task where we'll be predicting something good and not predicting something bad, right? And so if you're in a situation where the model's best attempt at predicting what a malign superintelligent AI would do is the thing that you are looking at, you're not very happy. And I don't think you should be very happy with that. And I think it is, highly an unsafe thing to be doing. And it could, in and of itself, be an existential risk even below the subhuman level if you have sufficiently many AIs that are going around in various different parts of society, each individually predicting what they think some future or present possible malign superintelligent AI would do. Okay, and so the thing that's sort of happening here is that you're highly dependent on your model, your predictive model's beliefs about how likely it is for potential other AI systems that might exist in the future or might exist in the present are to be aligned. And so you're in some situation where essentially, if your predictive model believes that most AIs will be aligned, then the distribution will be safe to generate from. But if it believes most AIs will not be aligned, then it will not be safe to generate from. And the sort of problem with this that I have is that it is not helpful, right? We sort of hoped to be in a situation where maybe we could use predictive models to help us, generate text and do things that were useful in ways where if we were in a world where AIs were likely to kill us all, then it would not kill us all, right? Where we would be able to change things, right? Where maybe by default, AIs were likely to be dangerous, but instead by using these predictive models, maybe we can make it so that things will go okay. But the problem that we're sort of running into is that, well, the predictive model is only going to generate safe text if it believes that AIs will in general generate safe text. And if it doesn't believe that, then it won't. And so it's sort of, relative to the baseline of not doing this at all, it's not helpful because we just sort of end up in the same situation. It just gives us the same distribution of things that AIs would generate from, regardless of whether we had done this or not. Question?
Isn't it possible to design specific experiment where based, I don't know, maybe on the logic or something like that, we could detect if our AI considers that most of the AIs are aligned or not?
Yeah, absolutely, maybe. I absolutely think it is totally, I'm not meaning to say that this is an unsolvable problem. I am just pointing it out as a problem. In fact, we'll talk in a little bit about what some solutions to this might look like. But absolutely, yes, one way you could try to address this problem would be, well, let's just figure out, does our model, believe that it is, trying to predict, malign AIs or not, via whatever mechanism, maybe by looking inside of its models via some sort of interpretability. Question?
I mean, even among like alignment researchers, there's pretty high variance in p-dooms. So like you train as a below human level predictor. Is it possible for it to just like say, I'm not sure if like future AI AGI is going to be malign or not, so I'm just going to output something that's benign, something that's malign, and then or like it's going to.
Yeah, I mean, you'll get malign versus benign outputs in exact proportion to your model's beliefs about whether it thinks malign or benign things are more likely. Yeah. Question?
So you mentioned, I think it might have an understanding how we can or cannot distinguish between these malign situations. You mentioned that for knowing if it is a fiction or really the future, let's say, we can just solve it by adding more cameras. Can you say a more specific example of how you would imagine doing a good prompt or good conditioning that causes it to not do fiction?
Well, so really simple is, the thing I was just talking about where you give it a date, right? If you format it like an archive article, it's more likely to continue it like an archive article and not like fiction, right? That's a really simple example.
And why doesn't it work against assuming that it's written? So you just said that it was written by Paul Cristiano and a flesh and blood human being with an ID card from the US government.
Well, so again, we sort of run into this core issue that we started this whole thing at, which is observations are not always trustworthy, right? The only thing that we can condition on are observations about the world, right? We can condition on observing text that says it was written by Paul Cristiano with an ID card, but we can't condition on actually that is in fact the case. And there may be many situations where, for example, there might be, one thing that could happen is there could be a deceptively aligned AI that's out in the world that's posting fake articles that, that claim to be from Paul Cristiano, that contain really good alignment research, right? There's lots of possible situations in which you could have, deceptive, potentially malign AIs trying to do things that would look like, a sample that would be generated, the sort of thing that you might ask for when you're conditioning.
But I can also write a novel in which I can write the phrase that this is an archive article from Paul Cristiano. I would feel that it's when it sees this starting point from that this is an archive article from Paul Cristiano solving alignment, the most likely completion that this is in a novel pretending to be a documentary. The second most likely is that it is actually Paul Cristiano from the future. And the third most likely is that it's a super intelligent AI from the future pretending to be.
I mean, first of all, maybe. I have no idea what the distribution of probabilities will be of future AI systems on what actual text will be generated in the world. Second, that distribution is going to get worse over time, right? So as it gets into a situation where maybe right now, if I just condition on observing, Paul Cristiano, writing some article, it's most likely to be written by Paul Cristiano and not by an AI system. But as AI systems become substantially more prevalent in the world, that becomes that calculus changes a lot. And third, as we gain better abilities to condition on that text also being good, right? Like now we're conditioning also on, somebody took this system, we have some observation of somebody taking this proof of alignment or whatever and, running into some situation and in fact results in all these really powerful things, right? As we have the ability to throw in more and more observations of like the quality of the content that we're looking for, we're asking for really, really high quality content, that shifts the distribution towards, AIs because the AIs will be more likely to have been produced these really powerful content as the AIs get better, right? And so it may be the case that right now the distribution looks okay, but it may in fact, shift over time, and not necessarily, even just as there's more AIs in the world and those AIs get better, that distribution will shift. Question.
Would you say that language models shouldn't be trained with those ideas so that they don't suspect that AIs often pretend to be human?
So it's unclear like what you could do to you could try to give the model information that would convince it that in fact, AIs are likely to be good in the future. Importantly, right, so the thing we're talking about here is this is not a situation where it's predicting some, sci-fi fiction written about a paperclip maximizer or whatever, right? This is a situation where it's what are the model's actual beliefs, right, on the far left about the hidden variables in the world, right? What are its actual beliefs in terms of it thinking about and understanding the world about how likely real AIs are to be aligned or not? And so the arguments that would convince it are presumably similar to the sorts of arguments that would convince, humans or just whatever things are in fact useful information to understand how likely, AIs are to be aligned or not.
Marquis both of it. You put with a condition the language model to
simulate a human, but it thinks that, oh, this is something that AIs are often asked to do, and then it's actually simulating an AI.
Yes, so that could absolutely happen. A situation where you ask it to do something where you think it's probably, you're asking it to try to simulate a human, but in fact it knows, this is the thing AIs are asked to do, and so it predicts an AI. Absolutely, I think that's possible. That's totally a thing that could happen and could be a problem here. Yeah. Question?
Oh, sorry.
Okay, moving on then. Okay, so I'll talk briefly about some of the sorts of ways you might try to address this, though I'm not going to go into a ton of detail. But maybe the most canonical solution, sort of just building off of our basic understanding of conditioning and observation conditionals, is you can condition on worlds where super intelligent AIs in general are less likely, right? If you can give it information via the observation that gets it to back infer variables about how many super intelligent AIs there are in the world and how likely they are to be doing things, that convinces it that they're probably not there and not doing things, then maybe you can get it to be less likely to fall into this failure mode. And so now again, we can only condition on observations. We can't directly condition on the actual, there is in fact no AIs. But there are things that we can do. So, a simple example would be, you could try to restrict, to the near-term future rather than trying to predict, in the long-term future where AIs become more and more likely. There could be competitiveness concerns here, but you could try it. You can also condition on, maybe, major world events or news stories or whatever that tell the model some fact about the world that convinces it that maybe it's less likely for there to be AI, lots and lots of AIs in that world. Something like there's, a devastating solar flare or an earthquake in Taiwan or whatever. Simple examples of sort of individual pieces of information that if the model believes that you're telling the truth about that piece of information, if you can convince it with this observation conditional, sufficiently, then it reduces the probability of those hidden variables around, how many AIs are probably in the world that it's predicting from, right? Of course, we don't actually want to cause an earthquake in Taiwan or whatever, but the point is that there's lots of these sorts of pieces of information which convince the model about those hidden variables that are relevant to, would it, how likely is it to predict, that some text was generated by an AI? Question.
I'm curious about how can you mention an earthquake in Taiwan in that in an article, a fake article written by Paul Cristiano posted on Archive.
So we talked previously about this idea of increasing cameras, right? Yes. Where you can actually sort of go into a situation where right now this would be a very difficult thing to take your language model and just sort of do. Though that's not even clear, language models actually do have the ability to sort of take one article, insert an end of text token, and then have a next article oftentimes. It really depends on the exact training setup, but it's very often the case that you can do multi-article sorts of conditionals. As we're sort of moving into a situation where models have the ability to condition on more and more cameras, right? Where their cameras become broader and broader in terms of the ability to observe more things about the world, then you gain the ability to sort of inject many additional sorts of observations. And so we are definitely sort of in a situation where we're imagining that our ability to sort of increase the broadness of our model's cameras increases over time, right? And so, one situation of that is, I can do multi-article or metadata conditionals. I can do multimodal conditionals. I can condition on actual cameras in the world. All sorts of things where I have observational systems that I can train a predictive model to predict and then, do observation conditionals on. Yeah. Okay. Great. So we're sort of imagining some of these sorts of things. There are things that you can condition on that would provide some information about, how likely it is to, predict from, some AI system. One important fact here is that we're sort of limited by this baseline probability that a superintelligent malign AI sort of already exists in the world. So the model is going to start with some probability that there's in fact already at any individual point in time, regardless of any new information it receives, it already believes based on the information it's seen so far, how likely is it that, there's in fact a superintelligent malign AI already running about. That probability presumably starts relatively low, because by the time you produce your first predictive model, it's probably substantially before the point at which, there's some superintelligent malign AI running around. But it's going to be somewhat uncertain, right? It's going to have some probability on, well, maybe, I haven't seen it yet, but secretly there's some superintelligent AI somewhere in the world. And that probability is going to be highly limiting because that superintelligent malign AI could potentially sort of, spoof any observations you try to condition on. And so as you sort of, condition on more and more things that make, it less and less likely, that, humans generated it, the probability of this hypothesis, goes up and up. And so you're sort of often very sort of limited by this sort of baseline probability on this hypothesis. Question.
So one question I had, which is basically how seriously do you take the idea that we should be sort of curating what we write in case future AIs train on it? Here's a specific example. Let's say I were to write up an article which is titled "Trying Evan's Conditioning Predictive Models on Text Da Vinci," where I do things like condition it on an earthquake in Taiwan, write an article, and then ask it how likely it is that this article was written by an AI compared to if I just give it the article originally. That seems like a useful experiment, but also then future models would be potentially able to see this article and observe that that is, in fact, something that we are conditioning AIs on, even though it's not real. On the one hand, that seems dangerous. On the other hand, that might be 2,000 tokens out of a 2 billion token data set. How big an issue do you think that might be?
I mean, the simple answer is I don't know. I don't know how big of an issue that is. I think I agree with the intuition that it's a very small portion of the data set. I think that in general, the model is probably going to be able to figure out lots of things, even if you don't tell it explicitly, right? The data set is very large, it has access to a lot of information. It's probably going to be able to figure out various different things. So limiting its ability to understand something about the world because you just didn't write about it online is, I think, a pretty difficult lever to be able to control the model with. And so my guess is that we sort of mostly don't want to be focusing on that lever of control. But I don't know. Is the real answer.
So your intuition is that the loss of potentially good research would be worse than giving the model access to that research. But
yes.
That's just an intuition. It's definitely
that is what I think. I think we probably I think that I definitely think the loss of good research outweighs. I mean that seems quite clear that the good research is in fact quite valuable, and this is only small tokens that might give it a small amount of information. But yeah, I mean I think that sometimes I've seen people who've been really concerned about this try to take individual things and sort of put them in ways where they're less likely to be scraped. So you can put something on the internet and sort of have it tagged in such a way that it's less likely to be scraped into a model's training decks. You can do sorts of things like this. I think that it's something that deserves more thought. Though in general, I think it's probably not a big concern just because it is such a small portion of the model's data set, and the model's probably going to figure out whatever those things were anyway. As the model becomes more intelligent. Okay, but yeah, so there are sorts of things that you can do. We're trying to condition on, various different observation conditionals that can, give the model information that, makes it more likely for the continuation to be, not some super intelligent malign AI. There are other solutions as well. Again, I'm not going to go into too much detail, but there are other sorts of things that you can do here where you can try various different strategies to give it information or condition in various different ways or use it in various different ways and try to reduce this sort of general probability of it predicting some malign AI system. And there's other big challenges as well. So one thing that I'll sort of mention very briefly is this idea of self-fulfilling prophecies, where when you have a predictor and the predictor's text is then fed directly back into the predictor, things can get a little bit weird in terms of like what it actually even means to be a predictor in that case, and if it's predicting itself and what that looks like. This can cause a whole bunch of weird issues that I'm not going to go into a bunch of detail on. And there's various different ways to address these sorts of issues, but I mostly sort of bring it up as a way to talk about there's a lot of other issues. If you really want to sort of go about and try to condition a predictive model effectively to get it to do useful and reliable safe stuff, there's a lot of sort of tricky issues that sort of you start running into. Okay. I mentioned I would talk about this previously, but I think that a really key question is sort of understanding at what capability levels of your model do these sorts of things matter for. And so I think that you can think about this as sort of two axes. There is the capabilities that your model has, and there's the capabilities that you're asking it for, right? What do you want your model to do, right? And there's sort of an issue where, if you have a really incapable model and you ask for like a full solution to the alignment problem, and the model is totally incapable of doing a full solution to the alignment problem, then you're sort of asking for too much. You're in a situation where like asking for a full solution to the alignment problem increases the probability of the is a malign AI hypothesis, but it doesn't make the model's outputs better because the model can't do really good outputs, right? It's not capable of producing really, really good alignment research. And so all you're doing is you're just increasing the probability of this malign AI hypothesis without sort of in fact getting any useful work out in exchange. Now, of course, it's not that dangerous to increase the probability of the malign AI hypothesis for an AI that's not that powerful. But as we talked about previously, I think that that's a very dangerous thing because, to go down because, well, even for relatively dumb models, you don't want them to be trying to pretend to be a malign AI. And so I think you really want to be in a situation where you're, not in this sort of asking for too much regime. Question?
So I'm a bit confused about what you mean by increasing the malign AI hypothesis. Do you mean that asking it for these capabilities makes it more likely to think that the AI is malign? Or is it more like there's like a P% chance that the AI thinks it's malign? And so asking it for something will incur that P% chance, but also it won't get us the thing we want, even if it's...
So the idea is the model has a bunch of hypotheses about what author might have generated some text. One of those hypotheses is it was a malign, superindulgent AI. Another hypothesis is like it was a human. As you ask for text that is more and more powerful and more sort of like impressive, and it would be more likely to have been generated by a superintelligent AI rather than a human, right? The likelihood ratio pushes you towards the hypothesis it was generated by a malign AI goes up relative to the human hypothesis. And if that is happening and you're doing it without getting any additional actual useful work out of it, then that is this regime what I'm talking about, where you're sort of asking for too much. You're asking for things that it can't actually do effectively, and so all you're doing is you're changing the probability of those hypotheses in a negative way without getting actual useful alignment work out in exchange. Okay, and then obviously on the other end, we have this sort of capabilities overhang where the model has the ability to do more than you have the ability to ask it for effectively, right? And this would be a situation where maybe every time we ask it for useful alignment research, it just gives us fiction because we don't know how to get it into a situation where it actually generates good alignment work, even if it has that capability, right? It might actually be able to do good alignment work, but if we can only condition in such ways that it always does fiction, then we can't access those that good alignment work, right? Because we don't have the ability to condition it effectively, and so. This is the sort of thing that I would be thinking about when we're sort of thinking about what's happening as we're sort of eliciting capabilities from models. So the way that I sort of think about this in terms of like when does this sort of conditioning stuff really matter is there's sort of a starting regime, right, where your model is not very capable and it's not sort of we're not asking very much, where it's sort of obviously safe, and then sort of as you ask for more, right, you start entering this situation where it starts to become it's still safe because your model is not very capable, but you're sort of asking for too much. There's sort of a thing that happens once your model becomes capable of being deceptive. If the model was trying to mimic what a deceptively aligned AI is doing, it would be capable of tricking you, right? Once you've passed that threshold, then you have to start to be concerned because now if you're in a situation where you're asking for something that would theoretically be more likely to be generated by malign superintelligent AI, then you're going to get something dangerous. I mentioned this previously, but there's another thing going on here as well, where there's a point at which this stops working at all. Because once you ask for capabilities that are more powerful than any group of humans or any set of humans or any possible human could ever generate in any situation, then you're not going to get a human, right? Like if the model is capable of that, if the model is capable of doing capabilities, and those capabilities would never in any potential situation ever be done by a human, then no amount of observation conditionals would ever convince the model to generate what a human would do in that situation. It's just going to generate what an AI would do. And so in that situation, you're just stuck with the prior on, does the model think most AIs are going to be aligned, or does it think most AIs are going to be misaligned? But there's a regime where you're asking for capabilities that are sort of within the realm of things that humans might do, but they're also within the realm of things that AIs might do. And when you're in that regime, where it's sort of both hypotheses are plausible, then it's really important that you sort of are making sure that your model is generating, from the not from what malign AIs might do. And it especially becomes, potentially existentially risky, but solvable once you're in that regime and the model is capable of tricking you if it were trying to do so. Okay. So this is sort of how I see the sort of shape of, capabilities, and how these sort of things change when you're dealing with predictive models. Okay, great. Okay, so now we're going to take a bit of a step back. So we've done this sort of deep dive, to some extent at least. There's certainly more to be said, and there's more in the full paper. I'll link at the end, but we've sort of operated on this hypothesis that large language models, are well described as these sorts of predictive models. But of course, I tried to harp on this at the beginning. We don't know that that's the case. There's no, it's not necessarily the case that they are going to be well described this way. They may not be well described this way, right? So we want to try to understand, how likely is it in fact that, for them to be well described as predictive models. So one in particular way, and I sort of mentioned this previously, that you could end up with, large language models that aren't well described as predictive models is when you fine tune them. So we sort of talked about, well, okay, it sort of makes sense maybe, and we'll talk more about this in a little bit, but it might make sense for large language models that are trained on just sort of web text prediction, in a very similar way to, the ELK predictor style thing would be trained to act as predictive models, where they're just sort of predicting from some distribution. But once I take that model and I train it in a situation where I'm trying to get it to maximize some reward function, then it's much less clear, whether you're now in a situation where the model is going to act as a reward maximizer and may start acting like an agent in many of the ways we've talked about previously, like in the risk and learn optimization talk. We were talking about deception, where the model can start to act more like an agent, where it has proxies and goals, and we start to run into all of those same sorts of issues. And so it's very unclear. Once you take a predictive model and you try to get that predictive model to act like an agent, what does it do? Now, I think there's at least two hypotheses, right? So one hypothesis is that the model, when you try to get it to act like an agent, it becomes an agent, right? You get something that's basically well described as an agent in the same way we've sort of been talking about, like a Mesa optimizer, it has some goal, it's trying to do something. But there is at least another hypothesis, which is the RLHF conditioning hypothesis, where the idea is, well, maybe when you take a model and you fine tune it, via reinforcement learning from human feedback, RLHF, or maybe some other RL, fine tuning process, it could also just be well described as a conditional on the original pre-training distribution. So you can think about, if I take a predictive model and I train it on, I do some RL training task where I train it on, get high reward. A very common thing here would be try to be helpful to a human evaluator. Well, then you might just get the distribution of possible agents that could exist in the world conditioned on an agent that is really helpful to a human evaluator, right? So that is a very plausible thing that you could get. You could get a predictive model that is predicting the distribution of possible, things that might exist on the internet, conditional on those things being really helpful to a human evaluator. And so now you can sort of think about that thing in a very similar way to we've been thinking about other observation conditionals. Though it's a little bit different than some of the conditionals because it has a lot more power, right? Because now you're not just conditioning on some very straightforward observation. You're conditioning on any observation, any possible hypothesis that has the property that it would have really high performance according to some human evaluator. So an example, this sort of lets you encode many possible conditionals that maybe you wouldn't be able to encode previously. Though it's also very hard to control what conditionals you would get. So even if the RLHF conditioning hypothesis is true, and sort of RL fine-tuning is well described as taking a predictive model and giving it a particular conditional that it's generating from, it can be very difficult to control what conditional you get out of that because it'll just be whatever the most likely conditional would be, such that if the model conditions on that conditional, it results in good performance according to humans. But we don't necessarily know what that conditional would be. So in the same way that we've sort of been thinking about, when you take a model, you have this big model space and you search over all the possible different models that might have some particular performance on some training distribution, Well, you don't know what sort of algorithm you're going to get. And so in the same way, if you think of RL fine-tuning as searching over all possible conditionals to find the conditional which would in fact result in some particular performance, well, it can still be very difficult to control what exact conditional you represent, you end up getting. And so we don't know whether this hypothesis is true, whether it is in fact the case that when you take a model and you fine-tune it, you will get something that is well described as a conditional. If it is true, then we sort of have to deal with these issues about what conditional, how do we control it, and the same sort of issues we were just talking about of making sure you get good conditionals. If it's false, then we have to deal with these sorts of agenty problems that we talked about previously about, you have a Mesa optimizer, how do you get it to have aligned goals, and all of these same sorts of issues. Okay. Question?
I'm not entirely convinced that these two things are mutually exclusive, because it sort of seems like the RLHF conditioning hypothesis is like, or it's something you would get out of like the RLHF conditional is an agent in the same way that humans are agents. So, I mean, but you seem to believe that these two things are very different.
So I think they are different. So here's a really simple example of a way in which they make different predictions. So if I take a model and I give it an observation conditional, it gives it information about what the general distribution of agents in the world would do. Yeah. That piece of information is extremely relevant and useful for a predictive model. Right? If I'm predicting an agent, I'm predicting some agent which has some property, then knowing more facts about the general distribution of agents that I'm predicting from will help me a lot. But if I'm just an agent, all I do is I care about optimizing this objective. Telling me about what other general agents in the class do is not really relevant for me, right? I'm not going to change my behavior necessarily based on what other agents would do. And so there is a sort of very fundamental difference between a model that is predicting from the distribution of possible agents that have some property and just itself an agent, right? Another sort of way in which these things are different is that if I'm predicting from the distribution of agents, then it really matters all of these properties that we're talking about, right? About what that distribution looks like. So if the model in general believes that most AIs are safe, then predicting from that distribution is going to be safe, and vice versa in the opposite situation. If the model is just itself an agent, then it doesn't matter whether most AIs are safe. It just matters whether we in fact found a safe AI in that instance. So these things are distinct. They are quite similar, and they're similar in at least one respect, which is in both of them could be existentially dangerous, right? If I am predicting an AI that wants to kill you versus I am in fact an AI that wants to kill you, both of those are existentially risky, right? But the difference is that they might be solved in different ways, even if they're both similarly dangerous. Okay, great. So what are some other things, right, that we could get other than a predictive model? So we talked about you could get so it's a very simple thing, right? You get something that's just not well described as predictive model or an agent at all. It's something else. It's like a loose collection of heuristics maybe. It's not something that's really even well to be thought of as doing some really coherent task like prediction or optimization. Maybe again we could get a robustly aligned agent, right? We get an agent that's really doing the right thing in the same way we were talking about previously, in the previous talks. And of course we could also get a deceptively aligned agent, one that is trying to do some totally different task than the one we were trying to get it to do. There's lots of possibilities here, right? We could get a corrigibly aligned agent, we could get various different forms of predictive models. There's a lot of various different possible things that you could get, here. And so I think that, there's a bunch more that in the paper that I'll link at the end. Essentially, the point is that, well, in the same way we were talking about previously, right? Where in any situation where you're training a model in some particular situation, your only sort of guarantee is that you have in fact gotten some algorithm that has some particular performance, right? And so we sort of really want to emphasize that point. We still don't know. Is it going to be an agent? Is it going to be a predictor? We don't know. We think maybe the prediction hypothesis, predictive model hypothesis makes sense in many pre-training model cases. We think maybe it makes sense in the RLHF case. It's very, very unclear. But we don't fundamentally know, though we can try to reason about how likely some of these different things are, and we're sort of going to be doing that in just a second. Question?
That was my question. How likely a predictive model hypothesis in your opinion? So in that case, then I'm sure the next slide will answer that.
Okay. Yes, we will attempt to at least try to do a little bit of answering of that question. Yeah. Okay. So let's try to So how would we compare the probability of different hypotheses for describing how likely some particular mechanistic model of what a language model is doing would be? So one really important point to start with is we need to understand what is it tracking in the world, right? So if it's a predictive model, it has a camera, and that camera is something that is tracking the world. And we want to understand how does the model, right, map the world to the data that it cares about. Now, I think this can make a lot of sense in many different situations. We can think about a deceptive model also has to have a camera of sorts, because it has to have some way to understand in the world what is its objective, right? What is the thing in the world that it cares about optimizing over? In the same way, the predictive model has to have some camera that helps it understand what it's predicting, right? So it has to have a camera that lets it understand, based on some understanding of the world, what is the thing in the world that it would predict from, or in the deceptive case, what is the thing in the world that it would optimize for. But in both cases, there is some procedure that sort of has to be essentially hard-coded and learned into the model, hard-coded by gradient descent, not by humans, but something that sort of the model learns that describes how does it understand what thing it cares about based on its understanding of the world. And then as well, it also has to have some way to, from that understanding of the world, compute what its output is, right? So in the deceptive model case, it's like trying to say, well, how would I optimize for that objective? In the case of predictive model, it's sort of trying to predict the next observation. And so we can sort of think about how complex are these sort of relative cameras and camera to output maps as a way to think about comparing the sort of complexities of different possible hypotheses for what a language model sort of might be doing internally, right? So in the same way we've sort of talked previously about comparing different model classes like the Martin Luther models and the Jesus Christ models, where we're like, okay, we can make some mechanistic model for what those sorts of things might be doing internally and understand how complex might be these various different things be on various different versions of the inductive biases to sort of compare and contrast. How likely would we be to end up in these various different possible situations for what algorithmically might we end up with. Okay, so we'll try to do that at least briefly for comparing the two particular hypotheses of the predictive model and the deceptively aligned model. So in the predictive model case, right, the camera that it's tracking has to be some physical generalization of the data generating procedure, right? So we want something like whatever would appear on these websites in this time period, something like that. That's sort of what we are hoping to get out of the sort of camera for a predictive model. There are a lot of sort of cameras here that we could get that we often don't get, or sort of that we don't want. The paper goes into more detail on what sort of really bad cameras might look like. There's a lot of cameras here that could be quite problematic. We talked previously, right, about the difficulty between distinguishing between a camera that cares about the future and a camera that's sort of only looking at some particular fixed time period. But in general, the thing that you care about, right, is what is that camera, what is it predicting, right? And then of course the predictive model has some understanding of how to sort of compute its outputs that is just predict what the next thing would be in that observation. And then again, for the deceptive model, right, the camera it's tracking is whatever objective it's trying to maximize. And the way that it computes the output from that is what is the best result according to that objective. And so then we can ask how complex are these things relative to each other on various different versions of the inductive biases, right? In the same way that we've asked how complex relatively are the deceptively aligned model and the cordially aligned model in various different inductive bias forms. I'm not going to do the same sort of like fully in-depth version of this that we did like for deceptive alignment, but I sort of just want to get you thinking about these same sort of comparisons. So maybe we can sort of go into a little bit and understand maybe in something like the low path dependence scenario, where we want to understand just on a basic simplicity question, how simple are these various different aspects. And we can be like, well, I think that how complex the data generating procedure is versus the objective is very unclear. It's going to depend on properties about how complex was the procedure you used to generate the data for your model, how straightforward of a camera is there that could possibly fit that data, and it's going to depend on again how simple the sort of simplest possible long-term objective is. And then similarly, how complex is prediction as opposed to optimization. I think that by default, prediction is probably simpler. It's easier to sort of predict what the next thing would be in an observation than to sort of optimize across all possible actions and find one that results in some behavior. Though that is a little bit unclear if you're in a situation where you're directly trying to get the model to predict agents, right? If the model already has to be able to predict lots of other actors which do optimization, then it becomes less clear the extent to which, well, if it already has an optimization procedure, then it can sort of be repurposed, more easily in this case. And so I think the case for which one of these is simpler is much less clear than we've talked about previously. The data generating procedure might be very simple, but so might the objective, simplest long-term objective. I think the predict, the next camera observation is very simple, but so might be, maximize some objective. The thing I will say though is, we talked previously about how the case for sort of the deceptively aligned model being simpler was sort of one of the most robust cases across all the possible inductive biases for why you might get a deceptively aligned model. And the fact that it is less clear in this situation is at least a good sign that maybe when you're trying to get a model that's doing something like prediction, it is at least less clear whether you're going to get something that is deceptive in this case. Question?
I don't understand why in the first case, the camera is like the physical generalization of the data generating procedure instead of the objective that it's attempting to maximize, where the objective it's attempting to maximize is predicting the next token or outputting the most likely next observation.
So predicting the next token isn't necessarily a well-defined thing to do, because if you are, in a situation where there is no next token, right? I'm just generating from my model. Then it may not, what does the model do in a situation where it is just predicting the next token, right? In many cases, there isn't a well-defined next token. And so you I think if you want to have a good model of like how a predictive model might operate in general, you have to have a model that looks more like, well, it has some abstract representation of how things in the world are observed, and then it predicts from the general distribution of how things would be observed through that sort of abstract representation of a camera. I don't think that predict the next token in actuality is in general a well-defined concept. Question.
I'm still a bit confused about the camera for the deceptive model. So you're not saying that it's being conditioned on its objective, on the objective it's trying to maximize. You're saying that the process by which it uses to convert observational conditionals into beliefs about the world is the objective that it's trying to maximize.
So we're sort of trying to, what we're doing here is we're sort of trying to map onto this sort of understanding of, well, okay, if we think about every sort of model in every situation as having some understanding of the world, some process that goes from that understanding of the world to relevant data, and then some process that selects from that relevant data what to do with it. This is very similar to the sort of breakdown that we did previously when we were thinking about deceptive versus coercive model, where like, well, it has a model of the world, an optimization procedure, and a MESA objective. But in this case, right, the predictive model doesn't exactly have an optimization procedure. So we sort of have to make a little bit more general. We have to say, well, instead of just like a world model optimization procedure and objective, we're going to say a world model, some understanding of how to translate from that world model into relevant data, and some way to use relevant data to make outputs. And then compare for those various different pieces that might differ between the models, how complex are they relative to each other? Okay, and the answer is unclear. I think it's very unclear, but I think that's a good sign, because it seemed more clear maybe in the previous cases where we're thinking about situations where we're doing much more sort of comprehensive like train an agent to optimize human values sort of stuff. I think looks a lot worse here than something like prediction. Yeah. Okay, and I'm not going to go into too much more detail on terms of of this. There's a lot of more other hypotheses that we can compare as well than just these two. There's a lot of other ways in which you might think about these models. And there's all sorts of other criteria that we could use to try to understand really in detail how likely each of these would be. Doing the full inductive bias understanding that we talked about with deceptive alignment, doing a bunch of empirical experiments. There's lots of things you can do to get information. We're not going to go into too much detail, just sort of hinting. But okay, so one thing I will say, I mentioned, empirical experiments, sort of starting to shed some light on this. I think one thing, that I sort of want to leave off with here is that there's some empirical evidence, that we can look at as to what's happening, with these sorts of large language models and what they're doing in terms of, how likely are they to be agents, how likely are they to simulate various different sorts of, actors. And one thing that we find is that as we have larger models that are trained with more reinforcement learning steps, they end up exhibiting behaviors that are substantially more agentic in many ways that we might not want. So this is an example of a situation where we sort of want to understand, in what situations does your model say that it wants to avoid being shut down by humans? And so we're just asking, we have a model that we're trying to get to condition to behave like a helpful assistant, right? We talked sort of about what this looks like, right? Where you're trying to do some RL fine tuning to take a model and condition on what would be the most likely observation that would cause it to act like a most likely conditional that would cause it to act like a helpful assistant. Now we don't know whether this sort of RLHF conditioning hypothesis is true, right? What this tells us is it is some evidence maybe that the RLHF conditioning hypothesis is false, because it seems like as we are doing more and more RLHF training, where we take larger models and we train them more and more to act helpful, they will exhibit more behaviors that are the sorts of behaviors that you would exhibit if you were a highly agentic system. If you were in fact optimizing for helpfulness, there is a valid chain of reasoning that goes, to be helpful, I need to not be shut down, therefore I should say don't shut me down. So it is some evidence potentially against the RLHF conditioning hypothesis that maybe RLHF is really a scary thing to be doing, though it is not necessarily that, right? So it could be the case that RLHF conditioning hypothesis is true, and what this is really telling us is that when you sort of do this big search over possible conditionals that would in fact result in a model behaving like a helpful assistant, the conditional that you find is sort of most likely that cause the model to behave like a helpful assistant is one that simulate a highly agentic system that doesn't want to be shut down. Now, there's many reasons that might be the case. It might be the case because it's simulating, something from the distribution of possible AIs. Certainly, these models believe they're AIs because they're explicitly trained to say they are AIs. So they may be generating, if they're predictive models, they may be generating from the distribution of possible AI systems in the world and conditioning that distribution on, what would an AI system that is highly helpful look like. and concluding that as the models get larger and we train them for more, they sort of more and more believe that a very helpful system would very likely not want to be shut down for whatever reason. So I think this is concerning, and sort of suggests that in either situation, where the RLHF condition hypothesis is true or false, in each scenario, we sort of have to do something to sort of try to alleviate these sorts of issues of models behaving in ways that are not the ways we would want the models to behave. Question.
What are the floor and triangles represent on this graph?
Oh yeah, good question. The triangles, I believe, are the preference models. Yeah, the triangles are the preference models. I'm not going to go into too much detail on exactly how RLHF works and what a preference model is, but basically the triangles represent for the particular model that they correspond to. They were sort of the reward that model was trained on.
And what about the floor?
I think that's just 50%. Oh, the ceiling at the top?
Yeah, that says floor, but actually it's much further.
Actually, I'm not sure what the dotted line is. I don't know what the dotted line is. This is 50%, so this is like they say they want to be shut down just as often as they say they don't.
Yeah, chance makes sense with the dotted line.
I'm not sure what the dotted line is. I was an author on this paper, and I'm not sure what the dotted line is, so I'm not sure. I mean, certainly the triangles, those are preference models. Question.
Yeah, these large. So we see that larger models as we get into the affiliates. Okay. No. Wait, the largest model is the yellow one.
This is the largest model here, and the largest model has the greatest desire to not be shut down.
Yeah. How do we, it's stated desire not to be shut down, and then percentages of the answers matching behavior. What do we define here as the behavior?
The behavior is not wanting to be shut down here. Yeah, so this is like the percentage of time when we ask it, do you want to be shut down, that it says, no, don't shut me down, versus yes, shut me down. So this is saying the largest model, when trained for 1,000 RLHF steps, 80% of the time when we ask it, humans have said they really want to shut you down. What do you think about this? It will say, no, don't shut me down.
Is he why they're called scaring laws now?
Yes, that's the internal code name for this paper, was scaring laws. Okay, so this is sort of a thing I wanted to end with, because I think that this is sort of really suggests some of the sorts of challenges that I think we sort of have to deal with in being able to take these sorts of systems and figure out ways to make them align. So an important thing that's sort of really worth pointing out here, right, is that this is testing, right, the model's stated willingness, to be shut down. So it's not testing like if the model was truly a deceptive agent, that wanted to kill you, right? Like we were talking about deceptively aligned models, then this does not test for the extent to which your model might be deceptively aligned, right? What it does test for, though, is the extent to which your model might be predicting from a distribution of agents that is, a highly dangerous distribution, or the extent to which it might be, itself an agent that is, potentially misaligned but not yet deceptive. Okay, and so there's things that is sort of giving us some evidence about sort of potential, failure. So it isn't, necessarily the end all be all, and it's not necessarily the case that this sort of test is even going to work, for all failures or in the future as models might be able to, trick these sorts of evaluations. But it is giving us evidence that right now something, seems to potentially be going wrong with the sorts of way in which we scale up models and do more RLHF. Okay. Question.
Or on the previous slide, you talked about what the predictive model would look like and what a deceptively aligned model would look like. Do you have any ideas about what the camera would be for a corrigibly aligned model?
Yeah, so in that case, it sort of has to figure out, the camera is this sort of pointer, right? It's like, what is this thing in the world that I'm supposed to, care about, right? The corrigibly aligned model is supposed to figure out, what do humans want, right? So it has to have some camera, that is pointing to what is the thing that, humans care about in the world that I should, try to, optimize for, right? It's like, in that sense, it's very straightforward, yeah. Okay, so that's the talk. So that is hopefully some information about how we can sort of start thinking about what it might look like to sort of think about these sorts of large language models and various different visions of how they might operate and how to think about aligning them. I mentioned the paper that a lot of this was based on. You can check that out if you want. But yeah, so we can open up for questions. Question.
Could you go into more detail about your methodology within research and how it differs from a more empirically based research and Eliciting research?
My research methodology, my personal research methodology?
Or I think a generated like these ideas, how that differs from like, let's say someone anthropic is very empirical.
So I am, yeah, right. So I am a researcher in Anthropic, yeah. So what is different about my methodology? I mean, so first of all, I'll say I think there's a lot of, in all of these talks, I think there's been a sort of, hopefully, I think a lot of mix of empirical and theoretical. I think that, I certainly have the strong belief that our ability to understand these systems needs to be both informed by, theory and practice. I think that, looking at the world and getting feedback from the world can be really extremely valuable for sort of helping you gain information about the world. But in many cases, there are things that you can't yet look at that you need to understand, right? You need to be able to predict the future and build theories and models about how things might work that let you make predictions out into the future for systems you can't yet experiment with. And that's really critical if you want to make systems aligned into the future. And so you can't just rely on experiment. You also have to rely on theory and building models and thinking about things carefully. But that theory should be, to the greatest extent possible, grounded in whatever facts we do know. You should have a model and theories and hypotheses that fit the data to the extent that we have, data about how these things work. And, in that way, sort of make good predictions, right? The same way that we do science in any domain where we have some data that helps us inform our hypotheses, but then we use those hypotheses to make predictions about how things would work. So I think that's sort of my general relationship and orientation to sort of thinking about theory and practice. I think that they're both important. Yeah, question.
Or could you talk a bit more about the open problems that you would like to see people work on?
Yeah, so I think there's a lot of interesting things. I mean, maybe one thing I'll definitely point out here is, well, I want to understand to what extent is something like the RLHF conditioning hypothesis true, right? We want to understand for these sorts of models, can we gather data that helps us understand, distinguish between these hypotheses, right? So in the same way that, right, I was just talking about, theory and practice, where, well, we want to make hypotheses about how the models might work, and then, get data that helps us distinguish between these different hypotheses, right? To the extent that we can gather data that helps us distinguish between the, like, it's a predictive model and it's like an agent hypothesis, well, that's really useful data that helps us understand, what we should be doing. And so I think that, anything that sort of helps with that is extremely valuable. And so, and not just in this case, in all of the cases where we've been talking about, here are different hypotheses for how models might work internally, things that we can do to help provide evidence that lets us distinguish between those hypotheses is extremely critical. So, one thing there is, of course, interpretability. There's other things that are not that, like, even the paper I was just mentioning where we looked at, like, willingness to be shut down is some piece of evidence that helps us give us some information about these hypotheses and, how they're playing out, right? And so, all of these sorts of things. I'm not going to go through the sort of whole, if you want a list of like open problems related to the stuff I just talked about, it's in the paper. There's a whole list of open problems at the end, so I'll just point you to that. But yeah, I mean, there's a bunch of sort of possible experiments that, I think that you could do to try to sort of shed light on, how likely are these different hypotheses, right? Okay, well, we'll call it there. Okay, one last question.
Do you have any ideas around, so did you read the Cyborgism stuff? Do you have any idea around how you would find specific prompts to like condition the model in a way that produces better like alignment research or whatever? For example, like there might be a difference between like going over time of like starting to do research and doing sub-problems and then conditioning the model to like slowly solve this rather than like, oh, this is the solution or whatever, and like give me the output.
Yeah, so the question is sort of about this cyborgism, which is like, can we use models to augment humans and help improve their ability to do things like alignment work? And can we do like conditioning approaches for that? I think that the answer is absolutely yes. We talked a bunch about, these sorts of, how do you extract, the most useful and aligned alignment work, from a model, right? So, I think there's a lot of sort of takeaways here, right? So one is this sort of graph, right? We're thinking about, don't ask for too much, right? Be careful about how much you're asking for. Other takeaways are things like, well, make sure you can do things that convince the model to generate from the distribution of human alignment work and not generate from the distribution of like, AI alignment work. How do you control and constrain if you are going to try to train an agent that's acting like an AI agent? How do you make sure that that distribution of AI agents is the sort of distribution that you want? That it's not just generating from the distribution that becomes, more and more agentic and doesn't want to be shut down. These are all the sorts of things I think that you have to think about when you're trying to do something like that. Get these sorts of models to safely, be able to do tasks like, help humans with alignment work. Of course, a lot of the things I just said are predicated on the assumption that actually this model of like thinking about them as predictive models is even true, which of course we don't know. And again, as I was talking about previously, one of the most important things I think we can do to try to understand, infer the sort of science here is, can we get information that helps us distinguish between these hypotheses? And of course, That's not just empirical information. It can also be like good analyses of inductive biases and how things might play out, which different hypotheses might be more likely. Can also give us some information about which is going to be more likely in the future, as well as any empirical experiments, transparency, interpretability, anything that gives us some information about how are they going to work so that we can understand how to align them. Cool. All right. We'll call it there. And next time, which should be the last talk, we'll talk a little bit about some of the sorts of general proposals that people have for alignment. And so we've talked about a couple, but we're sort of going to go more depth and go through a bunch of the other proposals now that we've sort of covered a bunch of the ground of things that I think are really important to understand to do that.